Today we will study Fourier transform. 5 questions we will take up today. First question is, what is Fourier transform? Second question, what are its roles? Third question, how it is applied in systems? Fourth question, why there is need of Fourier transform? Fifth question, what is the importance of Fourier transform? Now we will study these 5 questions in detail. First question is, what is Fourier transform? The Fourier transform is a mathematical tool that breaks a waveform and represents it as the sum of sinusoidal functions. Also, it can be defined as a technique that transforms a function of time xt to a function of frequency xf. It is closely related to the Fourier series. The Fourier transform of a function can be derived as a special case of the Fourier series when the period t approaches infinity. Now we will study second question. What are its roles? The Fourier transform ft is used to convert a signal into its corresponding frequency domain. The primary role of this transform is that it decomposes a waveform, which is a function of time, into the frequencies that make it up. The result produced by the Fourier transform is a complex valued function of frequency. It has special roles in digital signal processing and image processing for the better analysis of the signals or images. The output of this transformation represents the signal or image in the frequency domain. Now we will study third question, how it is applied in systems. The Fourier transform is used in the spectrum analysis of signals. It is also an important image processing tool which is used to decompose an image into its sine and cosine components. The output of the transformation represents the image in the Fourier or frequency domain, while the input image is the spatial domain equivalent. Also, the Fourier transforms are used in the resolution of partial differential equations, which appears in many mechanical engineering problems such as fluid mechanics, heat diffusion, and wave propagation applications. Now we will study fourth question, why there is need of Fourier transform. The main advantage of Fourier analysis is that very little information is lost from the signal during the transformation. The physical relevance of Fourier transform is that it tells about the relative amplitude of frequencies present in the signal. It uses all parts of the waveform to translate the signal into the frequency domain and maintains information on amplitude, harmonics, and phase. The Fourier transform is an important image processing tool which is used to decompose an image into its sine and cosine components, because any signal can be represented as a mixture of many harmonics. Now we will study last question, what is the importance of Fourier transform? There are many advantages which makes Fourier transforms very important. Some of those are as follows. The Fourier transforms are primarily used for steady-state signal analysis. These transforms are continuous transforms of continuous functions. These transforms easily resolves functions or signals from time domain into its frequency mode. The Fourier transform can be used to represent a general non-periodic function by a continuous or integral of complex functions. This transform is an important image processing tool which is used to decompose an image into its sine and cosine components. These transforms are used for analysis of electronics, acoustics, and communications systems. So this was all about Fourier transforms. In the next lecture, we will study Z transform. Thank you very much.